Today we are continuing systems of equations. So first we're going to review what we looked at before Thanksgiving, and then we will look at some equations. So if you remember before, systems of equations is where we have two equations, two lines, and we want to see, do these lines cross? Do they never touch, or are they the same line? Are they right on top of each other? So here we have an example of one solution where we can see intersecting lines. So here we have one solution, which means we have intersecting lines. We can see there is a point where these two lines cross. And if we look at this point, it looks like here it's at 2, and we go over and it's at 2. So this solution would be 2, 2. So some things to remember: the slope is different, and the y-intercept can be different or the same. But the big part here is that our slope is different. Those are not the same. Our second type is if there is no solution. We have parallel lines. So if we look here, we can see these lines have a space between them. They never touch. Those blue lines, there's no touching on them. So with these have the same slope, but a different y-intercept. We talked about this before. That means their b's are not equal. But here, the slopes are equal. So far we have intersecting lines. They cross one time. We have parallel lines. There's no solution. They never touch. And our third type that we have is infinite solutions. And this is where we have the same line. So if we look at the picture, all we see is one line. So here, everything is the same. Same slope, same y-intercept. So here, our slopes are the same, and our y-intercepts are the same. These are identical. Today, we're going to look at the equations to see, is there one, none, or infinite solutions? And we'll see how you can look at it in your calculator also. So here we have some examples. So in order to find our solutions, our equations have to be y equals mx plus b. They have to start with y equals. So if we look, here we've got steps. Number 1, change the equation into slope-intercept form. So we're changing it to y equals mx plus b. So if we look at number 1, here we have negative 3x plus y equals negative 1, and 6y equals 18x minus 6. So both of these we need to change to y equals mx plus b. So for the 6y, they already did take over x. So all I need to do is divide everything by 6. So then we would get y equals 3x minus 1. And then for this one on top, negative 3x plus y equals negative 1, I need to take over x, and then I get y equals 3x minus 1. So here, when I look at these equations, I've got y equals 3x minus 1 and y equals 3x minus 1. These are the same equations. So we can look at our calculator to see what this looks like on a graph. So step number 2, we want to press y equals. So we press y equals. We'll put the first equation in y1, so 3x minus 1. And then the second equation in y2. So I'm going to go to y2 and I'm going to type 3x minus 1. Then we'll press graph. So I'll press graph up at the top. And when you look, in the end, this line started off blue and then it changed to red. So here I only have one line. So that means that my answer for this would be infinite solutions, because I have the same line. Three minus 1, 3 minus 1. Those are exactly the same. If we look at number 2, I can see here I've got y equals 2x and y equals 1 over 2x minus 3. Both of these start with y equals, so I can go ahead and check my calculator. So I go back to y equals, and the first equation goes in y1, so my first equation is 2x. And then my second equation into y2. So my second equation is 1 over 2. So I'll get the fraction. That was alpha y equals 1 over 2 x and then minus 3. So then we press graph. And we look and we can see that these lines cross at a point. So to get this point, we want to press second trace 5. So I'm going to press second. Trace is at the top, the side graph. And we want number 5 where it says intersect. And then we'll press enter 3 times. So 1, 2, 3. And here the intersection, it says, is 2, 4. So for this one, if we look at our slopes, we've got 2 1/2. So our slopes are different. So that means we will have one solution, which when we look at the graph is 0.24. So this would be my final answer. One solution, that is 2, 4. All right, and then if we look at 3, the first one says y equals 5x, and our second one says 1 over 5y equals x plus 7. So we already took over x, but now we need to divide, or here, since we have 1 over 5, I can do times 5. These go away, times 5. So I get y equals 5 times x is 5x. Let's see. 5 times x is 5x, and 5 times 7 is 35. So now I have two equations. One is y equals 5x. My other one is y equals 5x plus 35. So if we go back to our calculator, again we go y equals, in y1 I'm putting 5x, and in y2 I'm going to put 5x plus 35. So now again we press graph to see the graph. And here I can see a blue line and a red line. But do these lines ever touch? These lines never touch. They're across from each other. So here, if we look at the slopes, we have 5x and 5x. So here our slopes are the same. So our answer is none. We have no solutions for these equations because on equation 1 it's 5x, but there's no plus 35. And on equation 2 it's yx plus 35. So the ends are different, but the slopes are the same. So our answer is none. All right, we're going to look at one more type, and then you'll get to practice. So this last question says, determine if the point given is a solution, is an answer to the system on the equations, to the system of equations. So we get an answer of 5, 2. So we want to see with these two equations, is 5, 2 the answer? So both of these, we need to solve for y. So I need to take over x. So I get negative y equals negative 2 over 5x, and then divide by that negative 1. So here I get y equals 2 over 5x. And again, I want to take over y. And divide by negative 1. So here I get y equals 3x minus 13. So my equations are y equals 2 over 5x and y equals 3x minus 13. So if I go back to my calculator, we start with y equals, and in y1 I want 2 over 5x. So I get my fraction 2 over 5x. And then in y2, I put my second equation, 3x minus 13. I'll push graph to see the graph. And here I see these lines touch one time. So to get the answer, we push second trace number 5, intersect. And I press enter 3 times. So I go 1, 2, 3. And when I look here, it says intersection is 5, 2. So for these two meet at the point 5, 2. And if I look here, I want 5, 2. Is this answer 5, 2? Yes. So here our answer would be yes, because the number on the calculator, 5, 2, matches the number in the question, 5, 2. Make sure to keep these steps where you can see them, because this will help you with the calculator. All right? Let me know if you have any questions.